Lunch and Learn is an MFG radio network production brought to you by GIE Media's Manufacturing Group. We highlight some of the latest innovations in manufacturing and design to help you gain insights to the newest products and technologies in the medical, aerospace, defense, and electric vehicle manufacturing industries to keep you ahead of the competition. Hello and welcome to our latest Manufacturing Lunch and Learn from GIE Media. I'm Jake Kaufman, the managing editor for the manufacturing group of magazines at GIE. We are glad to be joined today by Fagor Automation. Fagor Automation has vast experience in the development and manufacturing of products for machine automation and control. They offer solutions tailored to the needs of customers, from developing software to the versatility of their production process. Historically, Fagor Automation has focused on the machine tool sector, where they are one of the world leaders with a broad technical and sales network spread out in more than 50 countries through their branch offices and distributors. Today, we'll be joined by Ryan Adamovic, Fagor's marketing manager, and also Alejandro Escamilla, the national feedback product manager. Escamilla has been in the CNC machining industry for more than 25 years. He has since become the leading optical encoding expert at Fagor Automation North America, focused on generating solutions for unique customer applications requiring accuracy and dependability. Without any further ado, let's take over to Fagor.
Hello everyone, and welcome to today's GIE Media webinar. I'm thrilled to see so many of you here to explore what is truly an essential topic for anyone involved in CNC machining, whether you're an OEM, integrator, or machine operator. As the pace of manufacturing continues to accelerate, so does the need for uncompromising precision in the CNC processes. Achieving that level of precision is no longer just a nice to have. It's an essential, critical factor that can make or break competitiveness, especially in industries where quality control and performance are non-negotiable. In previous webinars, such as our Fundamentals of 5-Axis Machining, we discussed different CNC control algorithms that improve accuracy, such as high-speed surface accuracy algorithms and volumetric compensation. But utilizing CNC control functions alone will not achieve the level of precision needed for today's tight tolerances. There's simply no alternative to direct measurement. Today, we'll be focusing on a technology that is at the heart of this precision: linear and angular encoders. Encoders play a fundamental role in providing accurate positioning feedback, allowing CNC machines to perform with the repeatability and accuracy required by today's demanding applications. But as those of you who work in CNC know, it's never quite as simple as just adding a component and expecting perfect results. Accuracy and repeatability in CNC operations are continuously tested by factors. Factors such as thermal expansion, which can subtly distort dimensions, mechanical misalignments, which can throw off positioning, and the unavoidable impact of vibration in high-speed operations. Overcoming these challenges is essential for those of us aiming to achieve peak CNC performance day in and day out. In just a moment, we'll dive deeper into this topic with today's featured presenter, Alejandro Escamilla. Alejandro brings 25 years of expertise in precision feedback technologies and their application to CNC machining. He'll be walking us through the common challenges to CNC machine accuracy and introducing us to the advanced encoder technology that addresses these issues. He'll also be discussing some elements exclusive to Fagor encoders designed specifically to target these issues more aggressively. Whether you're looking to improve consistency, troubleshoot accuracy challenges, or simply want to stay on the edge of cutting-edge CNC technology, you'll gain valuable insights from his presentation. Without further ado, please join me in welcoming Alejandro Escamilla.
Thank you, Ryan. To set the stage, we will start with a technical overview of Fagor linear encoders. In today's modern machining of high-accuracy complex parts, over 95% of the machine tool makers use enclosed absolute optical technology, on their linear and angular encoders for position feedback. Absolute encoders offer many advantages over the incremental encoders, such as knowing the position at all times, including at power-up. This is a very valuable feature, especially for large machines. Absolute encoders also offer their latest mechanical and electrical technologies, such as Fagor's 3-state tech anti-contamination technology. They offer higher resolutions compared to incremental encoders and are more applicable with their absolute signals to various control protocols. You will also find non-contact linear encoders like exposed linear encoders and angular rotary feedback for applications such as CMM machines or microprocessing machines. Let's examine the measurement standard. These encoders use precise optical technology with a grading period of 20 micrometers, which is instrumental in enhanced measurement accuracy. The lower the grading period provides finer measurement resolution, leading to greater precision. Focusing on the engraving methods. It's important to ensure that the engraving method on your glass scale is consistent. This uniformity directly translates into more accurate and reliable position data. The clear and uniform etching allows for straightforward data interpolation without relying on extra processing steps. By contrast, other encoders design often use non-uniform engraving, which results in scattered data points. The encoder must utilize complex algorithms to compute position data, adding processing time and increasing the risk of errors, which can negatively impact CNC machine performance and reduce overall efficiency. This is why Fagor enclosed encoders all feature uniform engraving. In CNC machining repeatability, the ability to achieve the same position across multiple cycles is just as important and crucial as accuracy. Here, ultra-low subdivisional error, also known commonly as interpolation error, helps maintain consistent, precise signals, allowing for repeatable position for the encoder. Consistent readings are mandatory for reproducing parts of the same specification over and over, minimizing variation and providing high-quality finish in demanding applications. Additionally, Fagor glass scales are engineered with a stable thermal expansion coefficient, specifically 8 parts per million per Kelvin. This factor is essential because in high-precision CNC application, even minor thermal fluctuations can lead to errors in dimensions. In high-precision CNC environments, several sources contribute to these temperature fluctuations, potentially impacting position accuracy. For instance, friction in the ball screw mechanism can generate heat, especially when machining heavier parts. Motor heat dissipation and high-energy machine components also add to thermal load to the system, and even environmental factors like summer temperatures can affect machine stability. When temperature changes occur, components such as ball screw and machine structures may expand or contract, influencing position accuracy. Direct measurement methods are particularly effective for addressing these thermal impacts, as they reduce inaccuracies that arise with indirect measurements. This is why it is important to utilize glass scales rather than steel tape for high accuracy machining, even if the encoder is enclosed. Our encoders utilize glass scales due to low thermal expansion coefficients, ensuring that the scale remains stable when the machine itself experiences expansion. This ability allows the reader head to consistently scan the scale, maintaining accuracy along its full length regardless of temperature shifts. Additionally, a thermal determined mounting system, such as the one found on our encoders, is designed to synchronize with the machine thermal movements by allowing the extrusions to expand and contract along with the machine base. The mounting system supports accurate positioning without warping or misalignment from temperature changes. This careful attention to thermal management helps maintain CNC accuracy and ensure reliable, repeatable measurements even under varying thermal conditions. Mechanical stability within the encoder setup is essential, especially in environments with frequent or rapid axis movements. Encoder mechanical design isolates the reader head from the axis deviation, meaning that the harmonics from the machine do not affect the encoder's readings. This stability supports more accurate, reliable data in dynamic machining environments, helping to keep measurement precise even when the machine undergoes quick changes in direction and acceleration. There are two major methods when it comes to mechanical stability of the reader head: guided style and floating style. Guided style compensates vibration in 3 axes, resulting in a more robust design for mounting on the machine. Floating style, on the other hand, was designed for vibration compensation for only a single axis, leaving the other 2 without compensation. Loop time is a critical metric for CNC machines, reflecting how quickly the encoder can process and update position data back to the CNC control. In high-speed or high-precision environments, faster loop time translates into smoother and more responsive control over the machining movements, resulting in a mirror-like part finish. With a response time of under 5 microseconds, encoders can better support precise and stable operation, a significant factor in maintaining quality in demanding CNC operations. Our encoders can provide real-time position by reading the position every microsecond and communicating the position in just under 5 microseconds. On the other hand, some other brand encoders provide the position up to 31.3 microseconds, 6 times slower than Fagor. This is because the reader head has to complete a CCD scan with thousands of data points, calculate the position, and estimate the change in position since the initial CCD scan. Because our encoder does not rely on position estimation, it would be valid for modern CNC time loops, while other encoder brands with a slow loop time would be a choking point to the CNC. Let's look into why this critical difference can present a problem. Real-time CNC feedback is fundamental to CNC accuracy, as it allows for precise control and synchronization across multiple axes. Encoders that provide instantaneous position data can eliminate position error and ensure more accurate measurements. Real-time sampling minimizes potential errors by estimating inaccuracies, such as those caused by change in acceleration, something especially beneficial in applications requiring synchronized motion and high-speed algorithms. Let's look at an example of a real-time position provided by encoder compared to another encoder that utilizes estimated position calculations. The blue plot line represents the instantaneous real-time position sampling of one position per micrometer. The orange line represents another encoder brand that relies on estimated position due to slow loop time. If the CNC is requesting a report of the position every 40 microseconds, there will be a substantial difference between estimated position and real-time position when rapid changes in acceleration are encountered. When designing your CNC application with encoders, you should consider encoders with a closed loop sampling rate of one position per 5 microseconds or less. This will lead to near instantaneous position data with no estimation, guaranteeing your application is free of time-dependent position errors. One of the often overlooked aspects of encoders is their resistance to contamination and the ability to withstand adverse conditions. Materials like coolant and dust can interfere with sensitive components, so a protective design is key to keeping encoders functioning correctly over time. When a machine is powered on with active coolant, lip seals for encoders are the first and primary barrier preventing coolant from getting inside the encoder. Fagor encoders are designed with a high fluoropolymer sealing lip that shields internal components from dust, coolant, and other contaminations common in machining environments. This design enables extended maintenance-free operation, helping to reduce downtime and operational cost over time. Unlike alternative encoders that require a double sealing to achieve similar protection, Fagor's single lip seal design achieves the high resistance with minimal friction, enhancing performance while ensuring durability under the challenging conditions. However, when the machine is powered off for the evening or weekend, The coolant can vaporize and work its way into machine components, including the encoder. In absolute encoders, both linear and angular, the absolute position is calculated via a binary code of ones and zeros, similar to a barcode. This binary code is unique along the entire length of the scale. The encoder is able to calculate the absolute position by reading these ones and zeros. With traditional technology, if there is any contamination on the etching of the glass, the ones and zeros become less distinct. A 0 can be seen as a 1, and a 1 can be seen as a 0. In these cases, the encoder may have difficulties in determining the absolute position, generating an alarm, and consequently stopping the machine. Traditionally, an air purge would be used to overcome any contamination of the scales. Compressed filtered air is used to pressurize the extrusion to keep out contamination from ever reaching the optical glass. Something to keep in mind, the air purge solution is only as good as the maintenance and the quality of the air provided to the scale. It is critical to constantly replace your filters and prevent buildup of condensation inside the air lines. Another factor to keep in mind is that the air purge is not active when the machine is not powered on. As a result, any remaining coolant evaporates, and without pressurized air, the scale has the possibility of being contaminated with condensation. You may be wondering, does my machine application require air purge? Are there any solutions that are less complicated? The necessity of air purge depends on the scale location within inside the machine frame, especially in environments where the coolant comes in direct contact with the scale body, the most demanding work conditions. In these situations, we would strongly encourage that all encoders, no matter the manufacturer, take advantage of the air purge to benefit from the performance of the scale. In cases where the scale is installed in an area where coolant does not directly impact the scale body, air purge is unnecessary while utilizing Fagor's three-state technology. But before we get into that, another technology that Fagor has implemented to combat condensation is known as sensor compensation. This is an advanced software and electronics that self-regulate the intensity of the specialized photodiode reading, allowing us to maintain a consistent signal. The LED typically functions at 60% power. When the etching of the glass is obstructed by contamination, the LED self-adjusts to overcome and read the binary code. To provide you with the most dependable technology against contamination, pollutants, and vapors, a new solution has been developed that utilizes a third state to determine the absolute positioning. This new technology is called three-state technology. Three-state technology consists of a pseudo-random engraved code and the imaging technology that generates 3 different states if contamination is present on the track. This allows the system to discard the erroneous information, so only valid information is used to calculate the absolute position. Utilizing the embedded algorithms, the correct position is calculated with less information, yielding a more dependable encoder. Inaccurate position data resulting from the condensation is disregarded during the calculation of the absolute position. This is achieved through the utilization of advanced embedded algorithms in conjunction with 3-state CCD camera. The algorithm swiftly processes a 48-bit image to identify any questionable code in the absolute track due to contamination. This excessive optical technology guarantees flawless performance even when exposed to coolant contamination. Fagor tested encoders equipped with this technology on machines with a coolant-enriched environment for over 53 weeks. The machines were powered off on Friday and powered on Monday again, simulating standard machining hours. During the 53-week test, the encoders were exposed to various contaminations without positioning errors. The test results provided that 3-state technology can contend with contamination-rich environments. If you are in the Chicagoland area, I would be happy to welcome you to the North American headquarters so I can give you a tour. We also offer product demos and training at this facility, as well as our offices in Anaheim and Toronto. It has been a pleasure to present to you our latest innovations. My colleagues and I will answer any and all of your questions. Thank you for joining us.
So thank you, Alejandro, for that presentation. And like he said, we are glad to be joined by Ryan Adamovic, the marketing manager for Fagor Automation. We also have feedback sales manager Gary Chalczecki, who is going to be joining us as well to answer some questions from the audience. So Ryan, thank you so much for your time today.
Thank you for having us.
And here comes Gary as well. So it looks like we do have a few questions coming in. So the first one can be for obviously Ryan or Gary. But the first one that we seem to have coming in is, how can a legacy machine be retrofitted with these modern encoders?
I can take this question. So it's pretty common in our industry to take older machines and not only provide an update to the CNC control with a CNC retrofit, but to also update the encoders. When it comes to these older machines, we typically see a transition from previously installed incremental encoders to absolute encoders, which provide higher resolution and the ability to remember the position when the machine is powered off.
Okay. And then looks like Dennis wants to know, what is the maximum length of an absolute linear encoder?
It depends. On glass scales, Fagor can reach about 3.2 meters in length, but beyond 3.2 meters, we would have to go to a steel tape encoder, which we could still provide in an enclosed format, and that could reach up to 60 meters in length.
Okay, gotcha. Thank you, Ryan. Also, Amy says that she has a 20-year-old Lucas boring mill with incremental scales. Do they retrofit with absolute scales, and what would the improvements in resolution be like if they did?
Did you want to answer this one, Gary?
No, go ahead. I don't have
Sure,
that
yeah.
one for me.
Yeah, so we could retrofit that. And if we were to use absolute encoders, we would see a pretty big improvement in resolution. Typically that older type of machine would have TTL differential scales with 1 micron resolution. With today's modern absolute scales, you get down to 1 nanometer resolution. And we could also provide more contamination resistance, as well as thermal expansion resistance.
Okay, gotcha. And then the last question that I would have, obviously it's one of those buzzwords in the industry, but when it comes to Industry 4.0, even preventative maintenance, how can encoders be integrated into those sort of operations?
Yeah, so with today's encoders being absolute, we can actually measure the signal quality at the drive systems themselves. So this way, it maybe even once a year or whatever parameters you set on how often you would like to check with Industry 4.0 solutions, you can analyze the signal strength from the encoder and make decisions about what kind of preventative maintenance you would like to do based off of the signal strength.
Thank you, Ryan. Let's see. Does not appear that we have any other questions coming in. So I wanted to say thank you very much to Fagor Automation for the presentation today. Obviously, a massive thank you to Alejandro Escamilla, Ryan Adamovic, and Gary Chalczecki for joining us. I appreciate your time today, gentlemen.
Thank you for having us.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.